All right, to summarize, uh, this is my best explanation for the solar system. So, the basic ideas and problems. Solar nebulas form stars and planets. The star, when it turns on, evaporates what's left in the nebula, pushes it out. We have these hot Jupiters, and we have Uranus and Neptune. So, the evidence that we have is pretty strong that this is a natural process. We look around all over the place, and wherever we look, when we look in nebulas, we see stars and disks around stars. If we look around stars that are close to the Earth, or close to the sun rather, we see lots and lots of them. I mean, it's a cottage industry. We see, you know, what, 3,000 now? And the number just keeps on growing. So no matter where we look, we see stars with planets. We have these hot Jupiters, and the understanding that we have of this whole process is we start with a gas nebula. It condenses, forms a pancake sort of thing, looks like a pizza. The star turns on and drives what's left of the nebula away, and we're left with planets. Um, there has been a modification to the theory. Actually, Hal Levinson was quite involved in it. It's called the Nice theory or Nice theory. Models show that the outer planets could have formed by direct gravitational collapse, sort of similar to what the sun was doing. So it would have formed without without going through an accretion phase. So the Jupiters and Saturns could have formed in a few hundred years rather than taking much longer, like the inner planets did. And then they would have grabbed the hydrogen and helium before the sun blew it away. Uranus and Neptune would have been explained in the same sort of idea, because if you have these planets forming in this way, uh, these planets being Jupiter and Saturn, there's no reason why you couldn't have a few other ones. So there's lots of material there to create Jupiter, Saturn, Uranus, and Neptune, and perhaps a fifth one out there. And then they would grab all that stuff before the sun blew it away. So the idea, what we have is in the inner solar system, we have 100 planetoids coalescing into fewer and fewer until we're left with only a few, four: Mercury, Venus, Earth, and Mars. And let me remind you that this is the video that we have of this whole
animation begins
situation.
by looking at a very massive star late in life. At death, it explodes as a supernova, expelling matter outward and causing shock waves to impact nearby interstellar clouds. This act of violence triggers the birth of new stars, one of which is our Sun some 5 billion years ago. Early on, the formative solar system flattens into a disk, with the forming Sun at its center. Eventually, the planets begin to form by accreting matter that has not yet fallen into the Sun. Afterwards, the Sun's radiation and bipolar jets sweep away debris. Now, some 1 billion years after the solar system formed, 9 planets are mostly identifiable as worlds in their own right.
Okay, we'll stop there and we'll go to the current simulation that we understand probably explains the outer solar system. So it's the Nice model, and what we have is this is the beginning Oort cloud, and we have the Kuiper belt here. So that's what we are left with. This is sort of what we start with. Lots of material, and then we have the four planets, four outer planets here. The understanding is that these outer planets form closer to the sun, and they'll fling material out to here and into the inner solar system. and I'll just let this thing sail on. One of the things you'll notice is that these two planets will switch, as well as these two planets will sometimes be in a circular orbit and sometimes elliptical. So let's let it continue. Notice here, this is the age of the solar system. Notice how the Kuiper belt, this region here is getting devoid of material, and we are seeing an expansion of this planet's orbit. And now, look at what has happened. We have a switching of the orbits. The gold one went inside, the blue one went outside. So this is Uranus, and that's Neptune. They switch sides. So very interesting what's going on here. That's the current situation. Okay, now the last thing I want to do is show you the super planet crash. So let's see if we can get there. Here we go. Okay, so this is the website that you can go and play this game, and this is what it looks like. So let's see. Okay, it's pretty, see, it ends up going pretty quickly. I like to put in dwarf stars, and I like to put them, here we go. And now we'll put in a super Earth. And maybe we can stick another one in there. Oh, it looks like I have created a rather stable situation here. It's going to change something soon. But this is the sort of thing that, as you add more of these things in, here we go. It's sort of unstable. So we'll put in my dwarf, and we'll see if we can put another one in here. So it's kind of an interesting game. So we only have a couple planets here, and you see it's pretty stable, but if I add in another dwarf star, you can see that it's going to end very, very quickly. And I think I have one more orbit left, and that's it. Boom. So I'll leave it at that. We'll close it out. And basically it gives you an idea that to create a stable solar system, you need to have a sun that is really super large compared to everything else. You can have stars spinning around each other when they're far apart, but if you get close in, then you're going to cause the other objects to be thrown out. And that's what we saw with the nice simulation before, is with all those particles floating around, then all sorts of exciting things happen. And these are things that, if you're interested, you can create on your own as well. These are simulations that are actually available to you to create. Okay. Thank you very much.